So continuing on with integration, and so some other methods of integrating. And so the first one deals with substitution. And so for example, I want to integrate something that looks like this. So we want to integrate that, and we're going to do this by substituting, because we saw before last week that if we have something in our basic form, u to the n, we can integrate. And so here, we're going to say u is this thing that's all being raised to the power, and then du, now the derivative of this is 6x plus 4, and then we get our dx. So now I notice that my du, 6x plus 4, matches exactly what I have, and so we can substitute, and we now end up with the integral of u to the 4th du. And this we can integrate, because this is just our basic form, and so we integrate this, we get u to the 5th over 5 plus c. And then the last step is I need to replace the u with my original, and so we end up that the final answer is going to be given by that. And again, this was an indefinite interval. Again, we could tell that because there were no numbers there, and so for those, we do end up with an equation, and we do get that plus c at the end. So let's go through another example of this. And so this time, we have 12x squared 7x times 8x cubed plus 7x squared plus 9, 8th power. And again, we're going to do that by substitution. Again, the u is going to be this thing raised to the power. So u is going to be 8x cubed, 7x squared plus 9. My derivative of this is going to be 24x squared plus 14x. And we get that. So now we're going to make our substitution, and so it's going to be u to the 8th power, but now we got, okay, well, what do I got to multiply this by in order to get what I have in my actual question? So I'm going to multiply it by some factor to make them match, and if I look at that part, I have, what we had was 12x squared plus 7x. What we have down here is 24x squared plus 14x. Okay? And so you can tell by looking at that that the top is half the bottom. Okay? And so my factor in this case is going to be 1/2. And that goes out front of my integral. And so again, we're in our basic form where we can integrate. So this will be 1/2 u to the 9th over 9 plus c, which will give us u to the 9th over 18 plus c. And then again, the next step is to substitute back in, and we end up with 8x cubed, 7x squared, plus 9, all of that to the 9th, over 18 plus c. And we end up with our answer. So you got it in terms of substitution. Right? The next ones deal with natural log and e to the u. And so first off, we have something that's in this form, du over u. Then the outcome here when we integrate this is the natural log, absolute value of u plus c. And absolute value because logarithms can only be done of numbers that are positive. And so that's why the absolute value symbol we got there. So for example, we got dx over x plus 2. Well, again, I can say that u is going to be x plus 2. du, well, the derivative of x is 1, so du is just going to be dx. And so we can now substitute. And we end up with the integral of du over u, which is our basic form that I just had up above. And so when we integrate this, we end up with the natural log of u, absolute value of u, plus c. And then the last step is to substitute back in. And we end up with that. Okay. And then another one of these. And so let's do this one now. We've got x dx over x squared plus 6. And we have u is going to be the bottom term. And then the derivative of this, du, is going to be 2x dx. Again, we want to make our substitution. Right? And so we have the integral. And du over u. But now the question is about that factor return. So in the original, we had x dx. Here, my du is 2x dx. And so again, my factor here will be 1/2. So we can integrate this, so we end up with 1/2 the natural log of u plus c. Again, the last step is take the u out and plug the x back in. So we end up with 1/2 the natural log of x squared. And we get that. That's in terms of du over u. And so the next one deals with e to u. So remember when we did derivatives, we said that the derivative of e to the u was e to the u. And so the same thing here, when we integrate, we get e to the u. And so again, for example of this, let's integrate e to the 2x dx. And if I say that u is 2x, du will be 2 dx. So in our problem, we only have 1 dx. Du was 2 dx. So again, there'll be a factor. And that factor will be 1/2. So we get 1/2 integral e to the u du. We integrate this, we get 1/2 e to the u plus c. And then substituting back in, we get 1/2 e to the 2x plus c for our answer. And then one more this time, but this time one that is a definite integral. And so let's do this one. So we want to integrate 0 to 1, x squared e to the x cubed plus 1. So this one we're going to get a numerical answer. And so, again, doing some substitution, we're going to have that u is going to be x cubed plus 1. The derivative of that will be 3x squared dx. So du is 3x squared. My original is just x squared. So my factor here is going to be 1/3. And this will be e to the u, du. And we integrate e to the u, we get e to the u. And so this is going to be 1/3 e to the u, evaluate from 0 to 1. So this will be 1/3 e to the x cubed plus 1, evaluated from 0 to 1. The next step then is to plug in the numbers, and so we end up with 1/3 times e to the 1 cubed plus 1 minus e to the 0 cubed. Well, 1 cubed is 1, 1 plus 1 is 2, so this would be 1/3 e squared minus e to the first. So we end up with that, and then you should be able to plug that into your calculator and get the appropriate decimal for what that would come out to be. But you get it in terms of a definite, So we have, when we talked about derivatives, that we could do derivatives of the trig functions, and so we have in terms of integrating the trig functions. And so I'll put them all up here, and we'll go through example 1. So if I integrate sine, end up with you're going to get cosine. You end up with, you get sine. We integrate tangent. We end up with the natural absolute value. Cosine u plus c. So that's the first basic three, and then you get the reciprocal of these three. And so cosecant we end up with natural log cosecant u minus cotangent u. Secant natural log of secant u plus tangent u. And then lastly, the basic of the 6, we do cotangent and we end up with natural log of sine. So those are the 6 trig functions. So for example, one of these, let's say I want to integrate a cosine 1. So I'm going to integrate cosine of 6x dx, right? So we're going to say u is the 6x. The derivative of that is going to be 6 dx. So we can make our substitution. Well, this is a 6dx. My original was just a 1dx. So my factor is 1/6. So cosine u du. So when we do that, we're going to end up with 1/6 sine u plus c. And then the last step is to go ahead and make the substitution. So we end up with 1/6 the sine of 6x plus c. So we have in terms of the trig, right? Well, in terms of finding intervals, we can, Bentley intervals give you area. And so now we want to find the area between two curves. And so, for example, we got y equals 8 minus x squared. And then my other equation is y equals x plus 2. And in this case, let's actually change the colors here a bit. Let's make this y equals 8 minus x squared. And so we want to graph these. Right? So let's put them on a graph. This is a parabola opening downwards, maximum value of 8. And so it's going to look something like that. Right? My other one is an equation of a straight line with a slope of 1, y-intercept of 2, and so it's going to be looking something like that. And so what we want to find is the area in between. So what we want to know is what is that area in between those two points. And so we need to know to integrate. We're going to integrate, we want to integrate from here to here. So we need to determine what those numbers are. Okay, so at those 2 points, these two have to equal each other. And so we're going to have that 8 minus x squared is going to equal bx plus 2. So we want to solve this for x. And it's a quadratic, so we want to set it equal to 0. So the opposite of subtracting is to add, so let's take the x squared over. Add x squared, subtract the 8, and subtract the 8. And so we get 0 is going to equal x squared plus x minus 6. Well, that's a quadratic. It's a factorable quadratic. And so if we factor this, we're going to get an x and an x. It's a minus 6, so a plus and a minus. And then we need 2 numbers, multiply together, give you 6, and have a difference of 1. And so those will be 3 and 2. So this says that this times this gives you 0, which means either x plus 3 has to equal 0, or x minus 2 has to equal 0. So we can solve each one of those for x. So this one will give me x equals a minus 3. And this will give me x equals 2. So now we know we're going to integrate from -3 to 2. So now we need to set up our interval. Right? So the interval is going to be from -3 to 2. Okay? And it's going to be my quadratic function, which was the 8 minus x squared, minus my linear function, which was this. Right? So badly you would, in terms of which way you decide which one it is, you look at this, it's the quadratic function, this curve, which is basically holding in the area. So I'm going to do the quadratic curve, and then I'm going to take out that other piece due to my linear function. Right? So now that we got that, before we do our integration, we'll take care of the math part here. And so we have minus 3 to 2. 8 minus the 2 will be 6. Then we're going to have a minus x and then a minus x squared. Right? So all we did is take care of the math part first. Now we can integrate. So this is going to be a 6x, x squared over 2, x cubed over 3, evaluated from negative 3 to 2. So the next part is to number crunch this, and so we end up with 6 times 2 minus 2 squared over 2 minus 2 cubed over 3. That's the first number plugged in. Minus 6 times a minus 3 minus negative 3 squared over 2 minus a negative 3 cubed over 3. Right? So now it's a matter of number crunching this out. 6 times 2, that'll be 12. 2 squared is 4. 4 over 2 is 2. And 2 cubed, this will be 8 thirds for that part. Right? This will become, if I do this part, this will be 10 minus 8 thirds for that piece. Right? So let's go to my other piece over here. 6 times a minus 3, that's a minus 18. Minus negative 3 squared is 9. So this is 9 halves. Negative 3 cubed is negative 27 over 3, which is 9. And so this will become a plus 9. So you'll have minus a minus. And so on this guy, we're going to get a minus 9 halves for that piece. So this, I can rewrite as 30 over 3. So 30 over 3 minus 8 over 3 is going to give us 22 thirds for that piece. Okay. And then over here, 9 will become 18 halves. And so this side will give us a minus 27 halves. But then, of course, minus a minus means that this is going to become a plus. Now, in order to add fractions, we need to have a common denominator. And in this case, that number will be 6. So 3 times 2 is 6. 2 times the 22 will give us 44. The other one we're going to have to multiply by 3. And so this will become 81. And so this will give us 125 over 6, which will become 20 and 5/6 for the area in between those two curves. Right? So one more, and that is, what happens if I have one that looks like this? So now I got y equals minus x plus 2. And the other one is x equals, and again, let's change color. X equals 4 minus y squared. Again, I want to know what this looks like in terms of a graph. Well, this is just a straight line. Y-intercept of 2, slope of negative 1. So it's going to look something like this. This is a quadratic, right? But it's a quadratic that opens to the left or right. Okay? In this case, it's going to open to the left. And this quadratic is going to look something like that. Right? So we get my two curves. Now again, we need to know, well, where are they going to be intersecting, right? But now in this case, if I integrate with respect to x, I would get, if I do this with respect to x, I would only get that area there, okay? I'm missing part of the area, right? But if I integrate this, not with respect to x, but with respect to y, I now integrate going this way, and I get the entire area, right? So that means in terms of this one, I'm going to have my equations, and we want to integrate with respect to y. So this one is fine. This one I need to rearrange. So we have y equals a minus x plus 2. So if I take the 2 over, and we get y minus 2 equals a negative x, which means x is going to equal a minus y plus 2. Just change the sign. And now I need to find out where those intersection points are. So we got minus y plus 2 is going to equal 4 minus y squared. Again, it's quadratic, so we want to set equal to 0. So let's bring the y squared over. Subtract the 4. And so we get y squared minus y minus 2 equals 0. And now we want to solve that quadratic. And again, this is spot triple. So we get a y and a y, we get a plus and a minus. There's only one combination. So we get that, which means either y plus 1 equals 0, or y minus 2 equals 0. So we get y equals negative 1, or y equals 2. So we know where we're going to integrate from. So now, we can plug in. I'm going to integrate from negative 1 to 2. Right? Again, we got our quadratic, which was 4 minus y squared minus my linear function, which was a minus y plus 2. Right? Again, we can do our math part. 4 minus 2, this will be 2. We get a minus y squared, and then we get a plus y. Right? So now we can integrate. So this will give us a 2y minus y cubed over 3, y squared over 2, evaluated from negative 1 to 2. So the next part is the number crunching part of it. So we're going to plug in our numbers. So this is going to be 2 times 2 minus 2 cubed over 3 plus 2 squared over 2 minus 2 times minus 1 minus a minus 1 cubed over 3 plus a minus 1 squared over 2. we keep on number crunching that out. We got 2 times 2 is 4. That'll be 8/3. 2 squared is 4. So this is going to be 2. So this will be 6 minus 8/3. That part of it. Okay. Plugging in on the other side, we now get 2 times minus 1 is a minus 2. Negative 1 cubed is a negative. Minus a minus is going to make that a plus. And then this will be 1/2. Okay. And so if you put this all together, and I'll leave the rest of the math up to you to do it, but you should be able to do this and find out once you're all done that if you do all this out, that the final answer for this case, for this problem, will come out to be 9/2, and so everybody should be able to go through and get that fractional part done and complete that, and that will complete this segment on integration.